In the last two videos, we have learned about lists and maps. And up to this point, we have left to the compiler the task of deciding the types of the values inside our collections. Now is a good time to talk about another feature of the Dart language called generics. And generics are a way to improve type safety in our programs, meaning that we can use them to write code that is safer. So let me show you what I mean. In the main function over here, I'm going to define again the prime numbers list that we have seen previously. And this time I'm going to use a slightly different syntax. So here I can type var prime numbers equals, and then I'm going to type list, open and close bracket, and then semicolon. So this code that I have here simply creates an empty list, and in fact it is equivalent to using an empty list literal. So I'm going to use a Dart comment here to say that this list open and close bracket is equivalent to using open and close brackets like this. Next, I can type in prime numbers dot add all, and then within brackets I can type in 2, 3, 5, and 7 like this. And then I could add a new value and type prime numbers dot add, and this time within brackets I'm going to use single quotes and type Andrea like this. As you can see, the compiler doesn't complain about this code, and the reason for that is that I have not specified that I want the value of my list to be of a certain type. In order to fix this, I'm going to use generics to add a type annotation to my list declaration. So over here I can type in angular bracket, and then inside here I can specify type int, and then close angular bracket like this. And now we can see that when we try to add Andrea to the list, the compiler complains and it tells me the argument type string can't be assigned to the parameter type int. So because I have explicitly declared my list to only contain values of type int, then I can't add any values of a different type. Next, let's take a look at the map that we have defined here. As we know, map is a collection of key value pairs, and we can also use generics to add a type annotation when we declare our map. So one way to do this is to use angular brackets. So here I can open an angular bracket, and then we need to define the types of both the keys and the values. So here I want the keys to be of type string, like this. And in this particular case, I want the values to be of any type. And you can see here that the first value is a string, the second value is an int, and the third value is a double. So in this case, I can use dynamic as the type of my values, like this. And with this change, I could try to add a new value to my map and type, for example, person, and then choose a key that is not a string. So for example, the number 10, and then equals 20. And when I do that, I can see that the compiler complains, telling me that the argument type int can't be assigned to the parameter type string. So in summary, we can use type annotations to create code that is safer to use. But this is not the only advantage of generics. For example, let's suppose that we want to create a function that returns the first 4 prime numbers. So to do that, we could type in list and then get 4 prime numbers like this, and then we could use the arrow operator and then return a string literal 2, 3, 5, and 7 like this. However, if we omit the type annotation from our list, then it is not obvious what this type should be. Instead, if we say that this function returns a list of integers like this, then there is no ambiguity, and other people using our code know that this function will only ever return a list of integers. So to wrap up, I can say that using type annotations is not mandatory in Dart. However, we will use them whenever possible in this course because they make our code safer and easier to understand. Okay, so let's continue on the next video.